challenging because of the cost associated with it, as well as logistical demand. And often most of the monitoring or the sort of scientific surveys are limited by their spatial and temporal coverage. As a solution, this approach can be complemented by using or involving people who are interacting with these ecosystems. This can be achieved either by citizen science, culturonomics, or ecology approach. Unlike citizen science, the culturonomics and ecology collection of data, the people, they don't need to actively participate in the survey or in the study. Rather, we take a look on their cultural habits, or we generate data from the photo they took for fun. Then this brings us to the recreational angling, which is a global activity involving millions of participants. However, the angular generated data were underutilized for ecological research. As we know that the angulars are naturally motivated to catch large individuals, right? Because of the because of the pride, because of the honor associated with this. And most of the time, the angular, these catches are like precisely documented, measured, photographed, and often sometimes even shared in magazines and online platforms. And however, historically, these data were built as histories instead of a valuable source of ecological information. However, this perspective is changing, as we heard from the keynote speaker this morning. What this data can tell us, maybe the trophy data sets or the trophy catch may tell us the declining in the body size of the species, which may indicate overfishing. They may tell us the change in species composition, which may be indicator for change in ecology of a given ecosystem. Increasing the body size of the fish may also show the biological response of the fish for the change in environmental conditions like warming or productivity. Therefore, here we try to show how we can use these trophy data sets and provide additional insights into the regular monitoring or regular surveys. Here we used 4 large body that trophy size increase through time, and the larger individuals occur at the warmer environmental condition or at lower latitudes. In order to address our hypothesis, achieve our objective, we try to use a 15 years of trophy data sets generated from 2 angling unions in Czechia. And these data sets were from magazines as well as online platforms. We applied strict validation of the cache, the records, and this data these records were validated by the Angular Union experts, and at least each of the record need to have the length, weight, location, date, information in order to participate in these competitions. On the other hand, we have the environmental data sets. We extracted the average annual temperature as well as precipitation snow cover throughout Czech Republic from the Czech Hydrometeorological Institutes. We have 170 stations in Czech Republic, and we try to find the nearest station for each of the records, and we try to standardize, we try to apply, we try to standardize the temperature. We apply some kind of correction factor, and finally we get the long-term data set of the temperature for each of the records. Let's turn to the results. As you see, all 4 species shows increasing in the trophy size through time. Despite the variability among the species, all of them, they were showing increasing in the upper size limits. Parallelly, there is a gradual shift. How I can point it? Okay. There's a gradual shift towards the larger individual, showing that there is increasing in the upper limit or size of the fish through time. And our climatic information that we need for entire Czech Republic also showing the same trend. There is increasing in the temperature, average temperature, and also the precipitation is decreasing through time. When we try to examine the driver for this maximum size of trophy fish, we found that temperature as a significant factor, especially for grass carp, common carp, and European catfish. The maximum size limit associated with the warmer conditions. Of course, this is biologically expected. Warming can extend the growing season, which means allowing them to grow and to feed more. And another important point here is, as I mentioned in the introduction, these 4 species, their physiological optima exceeds 25 degrees Celsius. When the temperature increases, when the temperature rises, which means it approaches to the physiological optima. Therefore, that might be why that might be the reason why we saw the positive relationship between the increasing the maximum size limit in common carp, grass carp, European catfish, and temperature. And an important ecological detail here is in Czechia, the grass carp, common carp, as well as silver carp, there is no natural recruitment, and the entire population is maintained by stocking. Therefore, when there is stocking, which means like the density dependency, we can see the role of density dependency. There's low competition. They can efficiently utilize the resource, which could be one of the reasons, because there is no any extra energy for the reproduction. And the other, this thing may be the reason for the observed positive relationship between temperature and the body size of the warm water fish species. We try to explore the effect of altitude, on the maximum size limit of this warm water species. And as you see here, the fish from the lower part of the Czech, from Danube and Odra, they were growing, or they were reaching maximum size as compared with the ones in the upper region in Elbe Basin. And they are significantly higher. They are reaching, they are increasing in the size as compared with, there is a significant variation in the size, in the maximum size. And we try to also see the effects of habitat type or water type, because in the report, the anglers should report also like whether they are whether they fish from the Lotic or Lentic River or lakes. Therefore, from these data sets, we try to see the effects of habitat type or water type. And we found that European catfish is growing or reaching maximum size in lakes and the reservoirs as compared with rivers and streams. And we didn't find any kind of difference on the other species. Let me acknowledge the limitation of this study, and we believe that our approach may be influenced by the technological development of the gear, the improvement in the gear through time, because we are comparing historical data, right? Therefore, we acknowledge that the increasing in the maximum size of the fish observed in our study partly may be due to the improvement in capturing efficiency of the gear. We acknowledge that. On the other hand, also there might be a bias related to the behavior of reporting of the anglers. The behavior of anglers may be changed over time. They become selective over time, potentially influenced by the awareness or social media. And this may be the limitation of our study. And finally, from this study, we can conclude that using this culturonomics approach, we can get additional insights for ecological research. For instance, we cannot easily catch those trophy fish in a regular or in a standard survey. Therefore, if this approach can complement the regular surveys, additionally, it allows us to use the recreational angling data with their full potential. Thank you very much. Yeah.
Super nice, thank you. You mentioned increased catchability, gear innovation. For the carp anglers, there's also baiting. So they'll use ground baiting, and I know this can change the maximum size by 20 kilos if you do it a lot. And do you have any indication whether baiting amount, ground baiting, is correlated with temperature? So essentially that's causing the carp growth?
We don't have that kind of information, but we try to find some kind of indicator or a proxy to show the improvement in the gear, but we couldn't find it. But we can discuss it later, and still, yeah, we are developing. Okay.
We don't have time for additional questions.
Okay.
There's tea time available.
Okay.